Class, this is Mr. Castillo. In this video, we are going to compare fractions by rewriting each fraction as an equivalent fraction such that each fraction would have the same denominator. So, the first thing that we're going to do is look at the fractions and notice whether they have the same denominator or not. So this fraction is 3/4, and this one is 2/3. Well, I noticed that I'm comparing fourths to thirds, and this comparison is not fair because this is a whole that was cut up into 4 parts, and 3 out of the 4 were selected. And this is a whole that was cut up into 3 parts, and 2 out of the 3 were selected. Which is the greater fraction? And so to make that a fair comparison, we need to cut the whole into the same amount. In other words, we need to have the same denominator. And how do we do that? Okay, these are the steps. So you are going to write the multiples of both denominators, and you are going to find the least common multiple between the two. So let's go ahead and write the multiples of 4 and the multiples of 3. Multiples of 4 over here, and multiples of 3. All right, so, and as soon as we find a common multiple, the least one ideally, it can be any common multiple, but ideally you want the least one. So let's go 4. So we'll skip counting by 4 because we're looking for the multiples. So 4 8. Okay, you count 4 more, you get 12. You count 4 more, you get 16. Okay, you can keep going, but let me just start doing some of the 3s to see, because I can already see that there is a common multiple already. Okay, so we got 3 more, right? 6, 3 more, 9, 3 more, 12. So I can already see that there is a common multiple of 12. Okay, so that means that there is a common denominator that we're going to use for both. So I want this denominator, I want it to be 12, and I want this denominator to be 12. Okay, so this is going to be our common denominator. It's going to be 12. So now it's going to be a fair comparison. Now this fraction is going to be cut up into 12 parts, and so is this one. So it's going to be a fair comparison, but it's going to be equivalent. We're just creating an equivalent fraction. So now I'm going to think about how did I get to 12. So let me see. 4 times what gave me 12. So I know that 4 times 3 gives me 12. Whatever I do to my denominator, I have to do to my numerator. Okay, so here I have 12. So 3 times 3, all right, that's going to be 9. So here, how do I get 12 here? 3 times what will give me 12? 3 times 4. Whatever I do to my denominator, I have to do to my numerator. All right, 3 times 4, this is equal to 12. 2 times 4 is equal to 8. So now 3/4 actually turned out to be the same as 9/12. 2/3 turns out to be 8/12. So now it's easy to compare the fractions, because now with the same denominator we can just compare the numerators. 9 is bigger than 8, so 9/12 is the greater fraction. So we can say that 9/12 is greater than 8/12, such that 3/4, so 3/4 is greater than 2/3. Okay, let's see the next example. So again, we are comparing fractions using equivalent fractions such that each fraction has the same denominator. If you don't know how to generate equivalent fractions, search up my other videos that explains how to do it. But remember that we can create equivalent fractions by using multiplication or division. Okay, so here it tells us to circle the greater fraction in each pair. So here we have 2/10 or 26/100. So I've noticed that I have different denominators. Imagine that this is a chocolate bar that was cut up into 10 pieces, and I only ate 2 of those 10s. And this is a chocolate bar of the same size, but it was cut up into 100 pieces, and I only ate 26 of them. But remember, these pieces are much smaller because it's the same size as this one. This one was cut up into 10 pieces, and this one was cut up into 100 pieces. So you see where the problem lies, that it's hard to compare because the size of the pieces are different. The denominator is different. And it's hard to use benchmarks of 1/2 because both of these fractions are less than 1/2. So what we're going to do is that we're going to create equivalent fractions such that we end up with the same denominator. Okay, so just like we did in the other one, we're going to find the multiples of 10 and the multiples of 100. But I want you to notice something now. Remember, you just want the same denominator. So if you list the multiples of 10, and let's list the multiples of 100, okay, you can already see that the first multiple for 100 is going to be 100, right? 100. Let me just separate this. 110. Okay, it's going to be 100, and then when you skip count by 100, it's going to be 200. When you skip count, it's going to be that's 300, right? And then when you do the multiples of 10, it's going to be, right? It's going to be 10, 20, 30, 40, 50, 60, etc., right? You keep going, and eventually I'm going to get to 100. Eventually I'm going to get to 100, and 100 is going to be the least common multiple. Okay, that is going to be our common denominator that we can use. And notice that I can even use 200 or even 300 because all of these are indeed multiples of 10. But we want to use the lowest common denominator because we want to work with the smaller numbers, not with the bigger numbers. So that means that this fraction right here, 26/100, is already in my desired denominator. It already says hundreds here. So all I want is the 2/10. I'm just going to convert one of the fractions. This one, I don't need to convert it because this one is just times 1, right? Times 1 is going to give me the same thing. 26 times 1 is 26. 100 times 1 is 100. So it's going to stay the same, okay? So I'm looking to convert 2/10 into a denominator of 100. So I want my denominator to be 100. So I'm going to make an equivalent fraction for 2/10 with a denominator of 100 so that it can be a fair comparison. So I'm going to think to myself, 10 times what will give me 100? Well, I know that 10 times 10 times 10 is 100. Okay, whatever I do in my denominator, I also have to do to my numerator. So this one is also times 10. So 2 times 10 is 20 hundredths. So this 2/10, we just created an equivalent fraction. So this is equal to 20 hundredths. So now we can make a fair comparison. 20 hundredths or 26 hundredths. Which fraction is the greater fraction? Well, because they have the same denominator, all we have to compare is the numerator. Okay? It's like saying 20 apples or 26 apples. Who has more apples? Well, the 26, right? Because we're comparing apples to apples. We're comparing hundredths to hundredths. So 26 hundredths is the greater fraction. So now I want you to pause this video and try out the next one for yourself. Go ahead. Okay, I hope that you are able to pause the video and try out the next one for yourself. So now we're comparing 2/5 or 20 hundredths. All right, so again, step 1, look at your denominators. Notice that they are different, and this is a problem. It's difficult to compare fractions that have different denominators. And in this case, it's difficult to use benchmarks to compare them because both of these fractions turn out to be less than half. So they're very close fractions. Okay, so it's hard to compare them. We must create equivalent fractions with the same denominator. So step 1, list the multiples of your denominators. So my denominators are 5 and 100. So let me list the multiples of 5 until I could find the common multiple with 100. And notice something. I noticed something here. Okay, I noticed that, you know, the multiples of 100 are 100, 200, 300, 400, etc., right? And I know that 100 is a multiple of 5. Okay, so if you would list the multiples of 5, you know, 5, 10, 15, 20, 25, etc., right? You keep going. You're eventually going to get to 100. Okay? You are eventually going to get to 100. So 100 is going to be the least common multiple between these denominators. So this will be your denominator. Okay? You want the lowest common denominator. Okay? Because 200 is also a multiple of 5. So it's 300. You can use those too, but you just make it a little more complicated. Okay? So let's just go with 100. So this fraction, we don't have to change in this case. Okay? Because it is already in my desired denominator. So 2/5, I'm going to convert it into hundredths. So I'm gonna rewrite 2/5 right here. So let me write it right. 2/5, and I want equals an equivalent fraction with a denominator of 100. Okay, so well, I know that 5 times 20 is 100. Whatever I do to the bottom, I gotta do to the top. Okay, so 2 times 20. So 2 times 20 is 40. So 2/5 turns out to be equivalent to 40 hundredths. So which fraction is greater? 40 hundredths or 20 hundredths? Well, there are more hundredths here, right? Because it's 40 against 20. So 2/5 is the greater fraction. All right, again, let's work out another example. And I want you to pause this video to see if you can figure this out for yourself. So compare these fractions by using equivalent fractions such that each fraction has the same denominator. Circle the greater fraction in each pair. So go ahead and pause the video and try it out for yourself. Okay. Step 1. Look at the fraction. I see 2/3 or 7/12. And look at your denominators. Are they the same? Are they different? Oh, there are different denominators. I'm comparing two different things here. So I see that this is a piece of a whole, right? This is a piece of a whole, and the whole is made up of thirds. So this whole was cut up into the thirds, and 2 of them were selected. 2 out of 3. And this one is a whole that was cut up into 12 pieces, and 7 of them were selected. So imagine that this is a chocolate bar that was cut up into 3 pieces. The whole chocolate bar was cut up into 3 pieces, and you ate only 2 of them. And this is a chocolate bar that was cut up into 12 smaller pieces, but you ate 7 of them. Where do you eat the most chocolate? In this one, where you ate 2 out of the 3, or in this one, where you ate 7 out of the 12? Well, it's hard to compare because you have different sized pieces. You have different denominators. So to make it fair, let's create an equivalent fraction with the same denominator. So, step 1. Let's look at the denominators. We got thirds and 12ths. So you look at multiples of 3, and you look at the multiples of 12. So 3, 6, 9, 12. Wait a minute. 12? Oh, it's already right here. So 12. Okay. So this is my least common multiple. This is my lowest common denominator that I'm going to use, 12. So this tells me this fraction is times 1. I don't even have to change it. This will remain the same. So 7 and 12 stays the same. You only have to create an equivalent fraction for this side, because 12 is your desired denominator. So let's rewrite 2/3. 2/3 as an equivalent fraction. So what is your desired denominator? Your desired denominator is going to be 12. That's your desired denominator. Let's write it big over here, 12. All right, 12 is my desired denominator. And I'm looking to multiply this by something. 3 times what will give me 12? Well, if you look at the multiples of 3, that's 3 times 1, 3 times 2, 3 times 3, 3 times 4. So 3 times 4 is 12. Whatever I do to my denominator, I have to do to my numerator. Okay, 2 times 4 is 8. So 2/3 is equivalent, is the same as 8/12. 8 out of 12. So which is bigger, 7/12 or 8/12? Well, this one has more 12s. It has one more, right? 8 is bigger than 7. We're comparing 12s to 12s. We're comparing apples to apples. We're comparing oranges to oranges. We're comparing the same size pieces. So now it's a fair game. This chocolate bar is cut up into 12 pieces, and this chocolate bar is also cut up into 12 pieces. In this one, you ate 8 out of the 12 pieces, and in this one, you ate 7 out of the 12 pieces. So in which one do you eat more? Well, you ate more in this one because you ate 8. You ate 8 pieces. So 8/12 or 2/3. 2/3 is bigger than 7/12. Well, if you haven't paused the video yet and truly try this out for yourself, I want you to take the opportunity and do it now. Okay, pause the video and try this out for yourself. Okay, so now we're comparing 4/5 or 7/10. Step 1, look at your denominators. They're different. That's not fair. They should be the same. Okay. Create equivalent fractions such that they have the same denominator. So, let me see. Let me look at the multiples of 5. Let me list the multiples of 10. Okay. 5, 10, 15, 20. Oh, wait a minute. Oh, I already see the 10 over here. 10, and the multiples of 10 are 10, 20, 30. So wait a minute. I should use the least common multiple. Yes, it is true that I can also use 20. I can also use 30, because 30 is also multiples of 5. The point is, you should use a common multiple. It doesn't necessarily have to be the least common multiple, but it is recommended that that you use the least common multiple. So in this case, it's gonna be 10. Okay, so 10 is your desired denominator, and I've noticed that this is already 7/10. So all I really have to change is 4/5, and I want this to be 10. So 4 out of 5, my desired denominator is going to be 10. Okay, 10. So I'm going to ask myself, 5 times what will give me 10? Well, I know 5 times 2 gives me 10. Whatever I do to the bottom, I have to do to the top. 4 times 2. So 4 times 2 is 8. So 4/5 turns out to be the same as 8/10. So which fraction is bigger? 4/5, which is 8/10, or 7/10, where I'm comparing tenths to tenths, and this is 8/10 versus 7/10. So 8/10 is the greater fraction. So we can definitely say that 4/5 is greater than 7/10. And how do I know that? Because I created an equivalent fraction for 4/5, which gave me 8/10. And 8/10 is bigger than 7/10. Alright guys, I really hope you're learning this. Okay, this was the cool down in our lesson. Let's look at it again together. Jada, Kieran, and Lynn tried to run as far as possible before they had to stop and rest. Jada ran 3/4 of a mile. Kieran ran 7/12 of a mile. Lynn ran 4/6 of a mile. Who ran the farthest? Who ran the farthest before stopping? Explain or show your reasoning. So in other words, this question is asking which of these is the greater fraction. So we are comparing three fractions here: 3/4, 7/12, and 4/6. So to compare fractions like this, I need to have the same denominator. Okay, so I need to find the common denominator between 4ths, 12ths, and 6ths. If you really know your multiplication tables, you should immediately see that 12 is going to be your common denominator. So this fraction can remain unchanged. So let me just show you why that is true. Let me write. So these are my denominators: 4, 12, and 6, right? So let me look at the multiples of 4. Let me look at the multiples of 6. And let me look at the multiples of the 12. Okay, so 4, you list the multiples, right? 4, 8, 12. 6. Skip count by 6. 6, 12. 12, you start with 12, right? And you skip count by 12. Okay, 12, 24, etc. So 12 is going to be my least common multiple. So that's going to be my lowest common denominator between these fractions. So this fraction 7 out of 12, I'm going to leave it as it is. Okay, so I'm going to find an equivalent fraction for this one and for this one. So 3/4, I want this to have a denominator of 12. And I also want 4/6. I also want it to have a denominator of 12. So 6 times what gives me the 12. If you look at your multiples of 6, you can know that 6 times 2 is 12. Whatever you do to your denominator, you have to do to your numerator. You know 4 times 2, that's 8. So 4/6 is equivalent to 8/12. So here, 3/4, you want a desired denominator of 12. 4 times what gives you 12? Well, you know 4 times 3 gives you 12. Whatever you do to the bottom, you have to do to the top. So 3 times 3. So the 3 times 3 is 9. So now it's a fair comparison. So Jada ran 9/12 of a mile. Kieran ran 7/12 of a mile. And Lynn ran 8/12 of a mile. So who ran the farthest before stopping? I've noticed as I'm comparing these 12s that here we have 9/12, here we have 7/12, and here we have 8/12. And which is the bigger numerator here? Well, 9. So Jada ran the farthest. Okay. Who ran the farthest before stopping? Explain or show your reasoning. Jada ran the farthest because I created equivalent fractions for each. And notice that Jada ran 9/12 of a mile while Kieran ran 7/12 of a mile, and Lynn ran 8/12 of a mile. So that will be your explanation, and you will show your reasoning by showing me the equivalent fractions. Okay, class, I hope you were really able to learn. If you are still confused, just rewatch the video, skipping the parts that you already understand, and rewatching the parts that are still confusing to you. I'll see you in class.